Welcome to Ask and Learn.
Hello everyone. In the given figure, geometrically which is I have drawn is not logical according to dimension because I have not drawn by using the scale. So here it is given the angular velocity of the rod AB is 4 radian per second in clockwise direction and angular acceleration is 2 radian per second also in clockwise direction. We have to find in part A angular acceleration of rod BD, and in part B we have to find angular acceleration of dE. First we will write relative position of each point using the geometry. So RVA vector, you may write RVA minus 20 I cap. Remembering it, this direction we consider as a I cap, this is J cap, and counterclockwise as K cap. So these vector notation I am using here. 40 J cap inch RBB can be written as 40 I cap inch, and RDE can be written as 20 I cap minus 25 J cap inch. Now we will analyze the velocity. Velocity analysis we will do. For bar AB, I am writing the values again. Angular velocity of AB is given minus 4k cap radian per second. RBA vector is minus 20 I cap minus 40 J cap inch. So velocity of B point, you can write omega cross position vector of AB. Substitute the value minus 4k cap cross minus 20 I cap minus 40 J cap. So velocity of B point we will get minus 160 I cap plus 80 J cap inch per second. Say this equation to be 1. Now for bar BD, if we analyze bar BD, it would be angular velocity of BD is omega BD K cap. So velocity of V, you may write velocity of D to be velocity of V plus omega BD cross R dV vector. velocity of v already we have calculated. In the next step we will write this is omega vd k cap cross 40 I cap. Now substitute the value of velocity of v minus 160 I cap plus 80 j cap, and on solving it, this value you will get 40 omega vd j cap. So we can write velocity of d point to be minus 160 I cap plus 40 omega vd plus 80 j cap. Unit will be inch per second. Say this is equation 2. Now for bar de, for bar de we can write omega de to be omega de k cap. So velocity of d can be written as omega de cross rde vector, that is omega de k cap cross de position vector, which is 20 I cap minus 25 j cap. So on solving it, velocity of d you will get 220 omega de j cap plus 25 omega de I cap. Comparing I and j component of equation 2 and 3, I am writing the value directly. Omega de you will get minus 6.4 radian per second, that is in clockwise direction, and omega bd you can write minus 5.2 radian per second in clockwise direction. Now we will do the acceleration analysis for the same as we have done for velocity analysis. Now acceleration analysis. Angular acceleration of rod AB is given minus 2 k cap radian per second. Alpha BD we are assuming alpha BD k cap, and alpha DE we are assuming alpha DE k cap, which we have to find for bar AB. Acceleration of V point you may write alpha AV cross position vector RBA minus omega square AV RBA position vector. Substitute the value, you will get minus 2k cap cross minus 20 I cap minus 40 j cap. Omega is given 4, so 4 square minus 20 I cap minus 40 j cap. So it would be 20 to 40 I cap plus 680 j cap unit inch per second square, say equation number 4. Now we will solve for bar BE, first we will solve for bar BD. Acceleration of D point can be written as acceleration of V plus angular acceleration of BD cross position vector RdV minus omega square BD RdV vector. Substitute the value of all the three. This value is 240 I cap plus 680 j cap alpha BD k cap cross RdV 40 I cap omega BD 5.2 square 40 I cap. On solving it, acceleration of D point you may write minus 841.60 I cap plus 680 plus 40 alpha BD j cap. Say this is equation 5. Now we have to solve for bar BE. So acceleration of D point will be alpha DE cross RBE minus omega square DE into RDE. Substituting the value, alpha DE k cap cross 20 I cap minus 25 j cap. Omega DE is 6.4 whole square. RDE is 20 I cap minus 25 j cap. So acceleration of D point we will get 25 alpha DE minus 819.20 I cap plus 20 alpha DE plus 1024 I cap. All the value will be in inch per second square. This is 6th equation. So comparing I and j component of equations 5 and 6, you can obtain angular velocity of dE and angular velocity of vd, that we are writing here directly. So alpha dE, you have to solve, very simple calculation is there. So alpha vd, yeah, alpha dE you will get 0.896 in clockwise direction, and alpha vd you will get 8.15 in anti-clockwise direction. So these are the two answers for this problem. Thanks for watching it.